All right, I've got 11 o'clock, so let's get started. Um, we have a test coming up next week. It is exam 3. It will be on all the content since exam 2. You will be allowed a calculator because it will include the inductive sections that include some basic math. As I always warn people, I don't really think the calculator helps you. I think anyone in college can probably write these equations out by hand. And the real thing that's being tested is whether or not you understand how to set up the equation, which the calculator won't do for you. But that being said, you are entitled to a calculator next week. It will be the same format as the previous exams. You'll bring in a laptop. It will be all online, and you're expected to take it here unless we make alternative arrangements. It should cover everything on the syllabus that's marked up until exam 3. If there is a modification, I will tell you that the session before the exam, which will be next Monday. That being said, I did leave a little flex space in the schedule. If you notice, if you look closely, I listed the same section for 2 subsequent classes. So we should be able to stay on schedule. Questions about anything logistical? All right. I will note that I always enable statistic tracking whenever I post something to Scholar. So like last week when I posted those 2 PowerPoints to Scholar, I know exactly who and how many people downloaded them and who never touched it for 5 days. Despite the fact that they had 2 class sessions to do so. If you're in the 30% of the class that never opened the lecture from last Wednesday, just know that I know who you are. And it makes me less sympathetic at the end of the semester if you're asking for a consideration for, grades and stuff. So please keep up with the work. Please, when I ask you to, look at something, please look at it. If you need help, ask for it. But don't, this is not the time to slack off. We've got a couple weeks left. We just have to push to the end of April, and it will come up quickly. Oh, look at that. That's not a very interesting overhead. Let me see. There we go. All right, so for the sake of everyone, especially those who didn't even open this document, let me hit the most important thing that I hope you got from it. There's a couple patterns in translations that you're going to need to frankly just memorize. Some of these are unintuitive, which is why it's even more important to just flat out memorize them. I always tell people for things like this, the smartest thing to do is either to take a photocopy of your book or print out 1 or 2 pages off the PowerPoint, put it somewhere where you'll see it, the front of your notebook or on a cork board or something in your room, and just flat out memorize it. There's a couple different things that translate as and, that don't sound a lot like and. Things like but, yet, however, although, these are all translated as and. Sometimes in the English, they mean a little bit more than and, like but and however have the sort of implication it's and it also indicates that this somewhat conflicts with the previous information, where I say something like, the suspect had motive, but did not have opportunity. So it indicates, in English, it indicates somewhat of a conflict between the 2 claims. But for the sake of logic, all that's important is it's an and. Unless there's probably 2 legit ways to translate that, either as an or possibly a negated first half of the conditional. I'll only give you one of those 2 options on the multiple choice. Just if and IFF, which is if and only if, those are the 2 that always mean triple bar. Triple bar is where you're claiming the two sides are going to match. And I'll encourage you to remember our conversation about 6 weeks ago about the expression only if. Only if means something different than if. Only if introduces the second half of a conditional statement, no matter where in the sentence it occurs. If you got only if wrong on exam 1, I encourage you to figure out what only if means so that you get it right on exams 3 and 4. It's one of those things that I always warn students about. It doesn't work like if. So I would, if it were me, I would put a star next to just if, I would put a star next to only if, and I would make sure I understood how those are different than if. Necessary and sufficient. Necessary and sufficient are sort of philosophy jargon, logic jargon. You don't hear a lot of people in real life going around using the words necessary and sufficient. But just so you know, these are the 3 patterns that they translate as. A is sufficient for B means if A, then B. And that one I think is intuitive. The one that's really unintuitive is the second one, I think. A is necessary for B doesn't mean if A, then B. Because what it means is you need to have A for B, but A doesn't guarantee B. But if you don't have A, then you can't have B. So what it translates as is very unintuitive. It translates as if negated A, then it negated B. And it's one of the very few situations where you introduce a negation despite the fact that there is no negative word in the English. 98% of the time, the number of negation words in English, like not or don't, will match the number of negation signs in the translation. Finally, A is necessary and sufficient for B is a triple bar. So the necessary and sufficient for B, just if, and if and only if are the 3 that always indicate a triple bar relationship. All right, we're not going to do a ton of these, but I just want to get a feeling for where you are with this, and I think it's always good for you to have a feeling for where you are with this. So let's do some translations and sort of buzz and click in. So our session number is 289140. So let's try this. If she goes, then you'll be alone, but I'll be here. If she goes, then you'll be alone, but I'll be here. Good, yeah, we've got the if S, indicating an arrow. The comma indicates the S is going to be separate, so you're going to need an extra set of parentheses for the second half. And then you just have to spot that but is an and that's that's number 2. All right, let's try another one. Your car will start only if you have fuel. All right, if you got this one wrong, asterisk it and get it right on the test. Only if introduces the second term.
So only if introduces the fuel. So pattern 1 is correct. If your car starts, then that meant you had fuel. 57% got it. 43% did not. So please get that right on the exam. I think what's really confusing about this particular translation is, again, the only if occurs mid-sentence. But again, the only if always, always, always introduces the second term. I will quit unless you give me a raise. Don't ever say this to the administration. That conversation will not go well. Yeah, this was just a straightforward, one of these two is going to happen. I will quit, or you're going to give me a raise. Taking the final is a sufficient condition for passing. Yeah, wouldn't that be nice? Yeah, this one was pretty simple. If you take the final, then you pass. 85% got that right. Taking the final is necessary for you to pass. This is closer to true. Good, the 69% got this. Again, the proper translation means if you don't take the final, then you're not going to pass. And 69% got that. You are a man just if you are a rational animal. All right, good. 64% recognize the just if is the triple bar translation. So again, I think that's all we're going to do right now on this. But listen, especially the ones that you're getting, the right thing to do, the right way to take notes on exercises like this is to make note of ones that you either got wrong or ones that you weren't sure about when you entered them in. Because you want to make sure you get them right on the test. That's what's important here. This is just practice. Questions about any of this? How we doing? I mean, again, we definitely can bring up our translation here, work on it over the next week. All right, let's do a quick review on the PowerPoint that was supposed to be for Friday. You'll remember, and again, I'm going to breeze through this a little bit because it's not that different from our discussion on idiomatic arguments with Aristotelian syllogisms. But the point is similar in this sense. In real life, people do not lay out their arguments in their premise, conclusion format. Your job, when you are analyzing everyday arguments, is to put other people's claims into analyzable formats. So what you have to do is you need to find the premises and the conclusions Remember, an argument is a conclusion proven on the basis of one or more premises. A very common pattern of a properly formed argument in logical formal format is premise one, premise two, conclusion. Sometimes there are more premises than that. When looking at someone's argument, the easiest thing to do is to find premise and conclusion indicators. And you'll remember premise indicators include words like because, for, since, after all. I assume that, as we know, for these reasons. Conclusion indicators include things like hence, thus, so, therefore, it must be, it can't be. This proves that, this shows that. Or my personal condescending favorite is ergo. That's just something you use when you want to show people you know a little Latin. So again, if you don't remember the premise and conclusion indicators from last time, again, just print these pages out, put it in your study packet, memorize it. Most of these I think are pretty intuitive, but you know, maybe one or two you need to go over. When reading something in English, trying to put into formal logic, step one, identify the conclusion. And remember, look for conclusion indicators. That's usually the best hint. Also, look at the way the ideas in the argument fit together. The conclusion is what the argument builds up to. It's the point that it's trying to make. Conclusions are usually at the end of an argument, but not necessarily. Sometimes they're at the beginning of an argument, where somebody sort of starts off by introducing their conclusion. They can be in the middle. It's kind of an awkward way to form an argument, but it happens. And if somebody paid attention in English 123 and 223, they will give you an argument with the conclusion at the beginning and at the end. So those are some ways to look for the conclusion. Usually the conclusion is the most controversial thing in the argument, at least if the arguer was wise in the way they built the argument. Then, of course, you want to look for premises, look for claims that look like they're intended to prove or support the final ultimate claim. Premises, again, should be, or at least typically, less controversial than the conclusion. And of course, sometimes you need to look for unstated implicit premises, claims that are needed to be added for the argument just to make sort of minimal sense. So again, when we are analyzing things with the tools of critical thinking and logic, we want to be as generous to other people's arguments as we can be, which frankly is the exact opposite of what people in our culture tend to do. So if somebody else's argument looks stupid, you don't just say it's invalid. You say, well, wait a second. Is this guy just assuming there's something I know that he knows that he thinks I'll just assume? And then you add that to try to make the argument make sense. So if someone says, don't vote for him, he will destroy the economy, this implies something widely believed in our culture, that we shouldn't vote for people who would destroy the economy. You don't just run the validity test on it without adding the implicit premise and say, well, that's stupid. So you just like one of those people. That's when your bias is shown, when you don't even add sort of the obvious implied premise. All right. So most of that should be reviewed, both because you should have read this on Friday and because that's very similar to what we talked about when we talked about idiomatic arguments with Aristotelian syllogisms. Questions, thoughts? Yes. Sure. Actually, you know what? I did not bring my book. Let me find. Here, I have access to an electronic book. This will just take a second. This is 6.9, correct? All right, let's do this the old-fashioned way. Who's willing to lend me this book? You have a couple of mine?
Yeah, number one.
Yeah. Oh, yes, yes, good old Plato. Number one, knowledge can't be sensation. If it were, then we couldn't know something that we aren't presently sensing. All right, so knowledge can't be sensation. If it were, then we couldn't know something that we aren't presently sensing. What do we do first? We identify the conclusion. The conclusion here is the first thing it said. And I'm going to put not S for knowledge can't be sensation. That's going to be the conclusion. If knowledge were sensation, then we couldn't know something that we aren't currently sensing. Then not K for we couldn't know something that we aren't presently sensing. So we've got our conclusion, we've got the premise. What do you think we should do next? Yeah, you take a look at this and you say, well, wait a second. This looks a little bit silly. Obviously, there needs to be something added to this. What, when added to this, might result in that conclusion? And the answer is this. So knowledge can't be sensation. If knowledge were sensation, then we couldn't know something that we aren't presently sensing, but we can know things that we aren't presently sensing. And then if you do the tests on this, that will turn out to be a valid argument. Also, another hint, anytime someone like Plato, Aristotle, Kant, and if there's anyone super famous and smart that the book is quoting and it indicates that, the argument's probably valid. It might not be sound, but usually these people are smart enough that their arguments are properly formed. Was that the only one you wanted? Sure, I'm very happy to do number 3. Number 3, if they blitz but don't get our quarterback, then our wide receiver will be open. So our wide receiver won't be open, as shown by the fact that they won't blitz. All right, so first we identified the conclusion. So is the conclusion indicator. So our wide receiver won't be open. Not O. All right, first premise is going to be if they blitz, if B, if B, and they don't get to our quarterback. Remember, but is an and. So if B and not Q, then our wide receiver will be open. So our wide receiver won't be open, as shown by the fact that they won't blitz. As shown by the fact that is a premise indicator. And then that looks invalid. So we're going to let's do truth assignment tests. For not B to be true, B must be false. For not O to be false, O must be true. So yeah, this premise is going to be true no matter what we do with the Q, because it's going to end up with a false on the left side of the arrow because of the B, which will make the and false, which makes the left side of the arrow false. Also, since the O is always true, the right side of the arrow is always true. So it's, so yeah, that's an invalid argument. Which is one of the reasons why it, looks like, well, it just looks like you're missing something, but you're really not. And no matter what you do with the Q, it doesn't fix it. All right, you or anyone else for 6.9a? Yes, sir. Number 8. The filter capacitor can't be blown. This is indicated by the following facts. You'd hear a hum, presuming that the silicon diode works, but the filter capacitor is blown, but you don't hear a hum, and the silicon diode works. All right. So the conclusion appears to be the very first thing it says. The filter capacitor can't be blown. So not be. This is indicated by the following facts. That is a premise indicator. You'd hear a hum, presupposing that the silicon diode works, but the filter capacitor is blown. You hear a hum is going to be a consequence. The supposing, the presuming indicates the left side of the arrow, presuming that the silicon diode works. But is an and. The filter capacitor is blown. But you don't hear a hum, and the silicon diode works. All right, so it looks like that is the proper translation. And if we do truth assignment on it. Let's see, not H for that to be true, H must be false. For W to be true, W must be true. For not B to be false, B must be true. And then the first premise becomes false when you plug in these values from the other premises and conclusion. So the argument is therefore valid. So that's the proper translation, and the truth assignment test shows that the argument is valid. All right, well, I encourage you all to practice your skills on that, and I'm going to push forward to something new from 6.10. All right. So here's what we've been pushing towards. We want you to be able to do inferences from different claims that you're given. And this is how the more advanced steps in logic work, is that eventually I want to be able to give you a couple of premises and ask you from these 3 premises, try to prove this conclusion, and it might take you 10 steps to get from those premises to the conclusion. And at this point, what I'm going to do is I'm going to give you the tools, the kinds of things you can do with each kind of statement. There's at least one thing that you can do or infer from each kind of statement. We divide these into what are called S rules and into I rules. S rules are rules that when you have a statement, anytime you see that statement, you don't need anything in addition to that statement to make some inferences. And the most obvious one is and. So if I tell you that both A and B are true, from that you can infer that A is true. And also, shockingly, B is true. So if somebody says, my name is Silverman and I'm a professor, from that and statement, you can take either half of the and statement, and either half of that and statement is true. Easiest thing I'm going to say, really the rest of the course. That one's pretty easy. From an and statement, both half of this and statement is true. Note, this works with negative statements that are connected with an and. So if I say, I'm all out of peanut butter and I'm all out of jelly, from that you can imply, wow, he's all out of peanut butter and he doesn't even have any jelly. And it works with statements that are one affirmative and one negative. So if I say, I have peanut butter and I don't have any jelly, that means I have peanut butter and I don't have any jelly. Again, and is kind of the most obviously, this part's not rocket science. The hardest thing here is to remember this last bullet point though. If there is a negation outside the and statement, then all bets are off. You cannot do anything because once you add a negation outside the and statement, it's no longer really an and statement. It's a not both statement, and you can't use the and rules. So with all of the compound statements, negating them outside the parentheses completely changes the rules. So for ands, and for ands with negations inside the parenthesis, you can always be assured that whatever appears on either side of the and is the case. But as soon as you add a negation outside the parentheses, it throws off the rule and you can't use the rule. There's a separate rule for not both, but it's a much more complicated rule. All right, a second S rule. This is called the NOR rule. And this is when you have an or statement with a negation outside the parenthesis. And the way to read this is neither P nor Q, which you can infer from neither P nor Q, not P, and also not Q. Again, that sounds like something like, for some reason I'm obsessed with peanut butter and jelly. Let's suppose I say I neither have peanut butter nor jelly. From that negated or statement, you can infer that I don't have peanut butter, and I don't have jelly. Now note, it also works with negated negatives. And at this point, we're getting to phrases we don't usually use in English. But if I say, I neither don't have peanut butter, nor don't I have jelly. From those double negatives, you get two affirmatives. Yes? Yes, this is still an inclusive one. So when you see a negation outside an or statement, that negation will change the value of whatever individual has of the or statement you see. It will switch positives to negatives and negative to positives, and you can have one of each if you really want. I will warn you, that only works with the or. I see people on the test all the time try to do that with everything else. It doesn't work with any other operator other than or. So the sort of distributing the negation outside like the negative sign, that works, but it only works with an or statement, a negated or statement. It won't work with any other kind of statement. And of course, from P or Q by itself, that doesn't imply anything. There's a different rule for or. And or by itself doesn't allow you to infer things. You need an or plus a second statement that fits with the or in some special way. So and allows you to infer things by itself. Negated or allows you to infer things by itself. And the third one is a negated conditional statement. A NIF, this is sometimes called NIF, negated if then. From a negated if P then Q, you can imply the match of whatever's on the left and the opposite of whatever's on the right. So if I say it's not the case that if P then Q, then it means P must be true and Q must be false. And if I add a negation, so, and then if we were to make it a negated, not P, then not Q, then again, it still implies the match of what's on the left. In that case, that would be not P, and the opposite of what's on the right. And if we started with a negated Q, we'd switch it to a Q. So negated if then is a little confusing because you do the match of one side and the opposite of the other. So those are our three S rules where you see any of those three patterns, and if you see any of those three patterns, then you can do an inference. So here, let me reset this PowerPoint. Should just take a second. All right, and all right, good. All right, so from the claim P and Q, what is everything that we can infer from that? Just P, just U, P and U, or nothing? Yeah, that one's easy. Both, obviously. Good. How about from L or C? Can we infer L? Can we infer C? Can we infer both L and C? Or can we infer nothing? Good, yeah, from just an or statement, you can't infer anything. Now, from negated or, you can get a bunch of stuff. But from just the or by itself, you can't get anything. Next time, I will teach you a rule that lets you get something from an or statement if you have the right combination. What about from if, not N, then S? What, if anything, can we infer from if, not N, then S? All right. From a negated conditional with negation outside the parenthesis, you can get N and not S. But from a negation inside the parenthesis, you get nothing. Now, there's a way to get things with this if you have a second statement that interacts with it in the proper way, but by itself, this gets you nothing. This is what you're looking for. So I mean, this is a hard one because, well, now you know. Whether or not the negation's outside or inside makes 100% of the difference here. All right, how about this one? Good. So from the negated conditional, we match the left side exactly, which is F. Then we get the opposite of the other side, opposite of the right side, which starts as M and switches to not M. So B was correct, F and not M. All right, how about this one? Negated R or S. Good. Yes, from a negated or, you should switch the values of each half, and you can infer that out. So, number one is correct. How about negated J and not N? All right, now this one, the correct answer is nothing. Remember, from an and, you can get the match of each half, but if you stick a negation outside of it, then you can't infer anything. So always watch where the negation is, and anytime you have a negation outside the parentheses of any of these statements, it fundamentally changes the statement and it changes which rules you can use. Good. So negated or changes the values of each half. So the I switches to not I, and the not V switches over to V. So the 71% are correct. If F, then not G. Good. The answer here, of course, is nothing. From if F, then not G, we need a negation outside of it for you to use that rule. And it's not an and, so you can't just assume the truth of both halves. So only the arrow statement with negation allows you to do something with it on its own. Not Q and B. Yes, this is 64% are correct. Since there's no negation outside from the and statement, you can get the exact match of each of the two halves, which 64% correctly recognized. It is not the case of if H, then not I. Good, the 57% are correct. We have a negation outside a conditional arrow statement, which means we can get the exact match of the left and the exact opposite of the right. So from, it's not the case of if H, then not I, you get HI. Maybe one more. Yeah, from an or without a negation outside the parentheses, you get nothing. My encouragement to you is there is a chart on the top of page 143, and it shows how all three S rules work and how all three I rules work that we're going to go over next time. My encouragement to you is to photocopy, memorize, take a picture and a screenshot, do whatever it takes to master the 6 principles on the top of 143. And you want, 98 to 100% accuracy on this. You want mastery of this. Because if you don't have this, it will hurt you on both upcoming exams. Thank you very much. We will proceed on Wednesday. Enjoy the spring. Thank you for letting me look. Sure.
So,
Yes.
trying to see my grandparents the following weekend, not following, like the previous weekend. And I'm not 100% sure if I go up there, I'm able to come back down.
Where is that?
Connecticut.
Okay, have they published the final exam schedule yet?
Yes, ours is, I believe Thursday.
Here, let me look this up. All right, are you gonna be out of town on Friday, the previous Friday? When do you leave to see your grandparents?
I'll be leaving Thursday.
Um,
29th.
Yeah, I mean, I'll let you take it from a distance, but,
Okay.
you'll have to take it during the exam period.
Oh, I will be taking it during the exam.
Yeah.
It's just hard to get back here.
Yeah, I get that. I mean, I can. You